All right, describing data. And what we're looking at here, what we're going to look at here, are three different descriptions. Descriptions by measure of location, describing by measure of distribution or spread, and measure of shape, which if you looked at the histogram video, you've already seen distribution curve shape. We're going to come back to that and just quickly review it. Location. Every data set has a central tendency. In other words, there's a data that tends to be central to the data set. We use three statistical means to look at that. Mode. So you're simply going to take a look at your entire data set and you're going to ask the question or do a count, which number or which measurement happens most frequently. And so the most frequently occurring, if you assume you have measurements, the most frequently occurring measurement is then the mode. The median. Median is the middlemost. Now, to do the median, what you must do is you must actually rank order the data. 1, 2, 2, 2, 3, 3, 3, 4, 4, whatever you've got. And not just indicate that I've got 1 at 1, I've got 1, I got 2 here at 1, I got 3 at 2, I've got 3 at 3. Then what I'm going to do is when I do that, I'm going to find the middle. All right? Now, if I have an uneven number of samples, the middle is going to fall right on one of the values. In other words, if I had a set of 5, the third value in would be the middle. There'd be 2 above it and 2 below it. On the other hand, if I had 6, I'd fall in between the third and fourth issue. If you fall on an even set, if you fall in between, then what you have to do is you have to average the one to the left and one to the right, and that becomes your median or middlemost value. Third one, mean, is simply the average or x bar. And again, if you go back to the math video, here's the formula. The sum of x sub I from 1 to n divided by n being the number of samples, and that will give you the mean or average. So location, central tendency. You can evaluate it with these three. You want to do all three and see how they line up. If you have a normal curve, you're going to find that all three of them are going to be pretty much the same value. They're going to be right together. We'll come back and talk about that a little later. Dispersion. This is the one that gives everybody fits. We're talking about the amount or the spread of variation. And we have two statistical calculations we use with that, range and standard deviation. Range is the easy one. Standard deviation, we'll talk about that. It's a little more complex. But what range does is simply takes the high value in the data set, subtracts the low value from the data set, and gives you the range, or the amount, amount of variation in the set. There's a problem with range, and what I'm trying to do here is illustrate it. Let's say that these are my measurements or my values. I've got 1 at 2, 1 at 3, 4, 5, 6, 7, 8, 9, and 10. 10 minus 2 is 8, so the range is 8, and granted it is. There is a range of 8 units of variation in there. However, what if I have one down here at 1, 1 at 4, 5, 6, 7, and 1 here at 9? Notice it's not a nice even spread, but the range is still 8. Finally, worst case scenario, suppose I got 1 here at 2, and then I've got 6 and 7, 9 and 10. Again, my high minus my low still gives me a range of 8. So in all cases, all three cases, what I have is I have a spread of the variation, or amount of variation, equal to 8. But they're all very different patterns. So what range doesn't do for me, it tells me how much variation is there, but it doesn't tell me what it looks like or how it lays out. That's when standard deviation comes in, and that's the value of it. Because standard deviation will show you the average dispersion or spread around the mean. Now, the calculation for it, this is the sigma, lowercase sigma. One standard deviation is equal to the square root of, the sum of each sample minus the average of the samples squared. We get a sum of all that and divide it by the number of samples minus 1. Now, I want to draw your attention to this guy right here. If you see n minus 1 in there, what you're talking about is a calculation of standard deviation when we have a sample, meaning we don't have all the data. We've got a subset of the data. Maybe I've got 500 measurements out of 10,000. I have a sample, all right? And therefore, for a standard deviation of a sample, it's n minus 1. If I had the entire population, in other words, if I had 500 measurements and I had all 500, then this would not be n minus 1, but would just be plain old n. In other words, there's no reason to decrement it by 1 if I have the entire population. Usually I don't. I have a subset of it or a sample of it. Therefore, you're going to see the n minus 1. But just keep in mind, this is for a sample. This would be for the entire population. And like I said, we don't have too often have that. What I've done here is I've just kind of laid out a little sample of how this happens to help you see why you want to learn to use your calculator to do this, or actually better yet, why you want to learn to use a spreadsheet to do it. And most spreadsheets will do it. If you're using Excel, OpenOffice, LibreOffice, a couple of the free ones that you can get, even Microsoft Word spreadsheet, they will all do this for you. They all have standard deviation in them. So what I've got is I've got 9 values here, 26.0, 23.0, 22.0, and on down. The average of my 9 is 23.0. That's my x bar. Remember, average, right back here. There's the average of all 9. All right, so now what I'm going to do is I'm going to take the x value, which is the 26, reduce it by the x bar, and that gives that subtraction gives me a difference of 3. Here, a difference of 0. Here, 22 minus 23 gives me a difference of negative 1. 25 minus 23 gives me a difference of 2. And again, 26 minus 23 gives me a difference of 3. You can see the differences. Now what I'm going to do is I'm going to simply square this value. Remember, a squared value will always be positive. And the reason for that is the basic rules of signs. And multiplication, if the signs are the same, the result is always positive. It's only negative if the signs are different. Well, positive 3 times positive 3 is a positive 9. 0 times 0 is 0. A negative 1 times a negative 1 gives me a positive 1. 2 times 2 is 4. 3 times 3 is 9. Therefore, I now have this value here. I have the square of these. I total them for a total of 44. I don't have all the numbers here, but trust me, it was 44. So now I'm at a point where my standard deviation is equal to 44 divided by 9 minus 1. Or in essence, this would be 8. That yields a value of 44 divided by 8 gives me a value of 4.888 ongoing. I take the square root of that. I get 2.2, what runs out. I'm going to round it to, let me get a different color here. I'm going to round it to the precision represented by the samples. So I'm going to say I have a standard deviation here of 2.2. What that means is from the mean, from 23.0, all right, the data starts to spread out in increments of 2.2. And out it goes. Standard deviation. Like I said, it makes a real quick believer of you of spreadsheets. You definitely don't want to be messing around manually with this. Most calculators, the TI-36 Pro has it in, but in terms of a data set, it's a lot of numbers to key in, and you probably, I don't think it handles more than, I want to say, 20 or 30 values in there, so it's limited. Again, your spreadsheet is your best bet on this, or some statistical package that will do it. All right, the third one then, measures of shape. I'm going to move back here and get a little space. We really don't need to spend a lot of time on it because we've already talked about it in the histogram. Normal distribution curve. Mean, mode, and medium are all going to be right there or very close to that, right in tight to the center of the curve. If you see a skewed curve, let's start with a skewed right. Let's over here put a skewed left. Here's what you're going to see. And it will be consistent. It will start with mode. Okay, come to median and mean. And the same over here. Mode, median, and mean. Okay, the values are not going to be tight. There's going to be some variation or difference between them. And if it's skewed right, you'll see that it will go, remember, we're going from high to low. We'll see it go from mode to median to mean. Over here, if it's skewed left, we'll see it go up from mean, median, mode. There's the pattern. So in reality, once you calculate these three values, you actually, if you take a look at them in their relationship one to the other, you can tell without even drawing the curve whether you've got a normal curve or a skewed curve. That's what we call measure of shape.